Hey, hey, hey. I have no video. Hmm. I have no video. All right, stand by. There we go. Hey, hey, hey. Let's I've got to reload that. It must be 2 hours UTC because it's time for Astronomy Daily Live once again. Looks like we're running a little wonky tonight for some reason. That is life. Life is pretty wonky sometimes. Just go with the flow here. Hope everybody's doing good. You can call me Cosmic. And here we are on the live stream talking astronomy for the next hour or so. Hope everybody's doing well. Hope your last 20 million miles was smooth and maybe even a little bit fun. Mine's been pretty interesting. Yeah, so I'm watching my live stream over here, and for some reason I'm pretty wonky. I'm thinking maybe it has to do with my countdown timer, so I'm going to get rid of that. Get rid of that and see if that solves it. I think it does. So, Astronomy Daily Live is a daily live stream where a circle of friends comes together every single day and talks astronomy for an hour or so. I'm going to go ahead and tweet that I am live. I'm trying to remember to do that. I've got a couple hundred followers on Twitter, and I never seem to let them know when I actually go live. So I'm going to do that very quickly. Bear with me. Bear with me as I try to grow the circle of friends. If you're joining me new, have never been on here yet, maybe somehow came across this live stream, we definitely appreciate you subscribing, and you can hit the notifications. There's a notification bell that allows you to well, be notified when this live stream goes live, and that way you don't have to figure out for yourself when 2 hours UTC is, because of course it's different depending on where you are on the planet. I'm located in southeastern USA in the United States, so I'm on Mountain Standard Time. And do I need to do that? I don't need to do that. I don't need to do that. I just need to grab that because I'm going to tweet it. So I'm on Mountain Standard Time, which means that I am 7 hours behind, um, 7 hours behind UTC. So at 2 hours UTC on February 2nd, or March, it's now March 2nd. It's actually 7 p.m., specifically 7:05 p.m. Here, Mountain Standard Time, my local time. All right, so I'm just tweeting that out now so I can get back to focusing on this. And let's talk some astronomy for a while. There's always something to talk about when it comes to astronomy. The science of astronomy covers everything, everything. So from subatomic things that you can't even imagine being able to see, to the infinitesimally small time periods, to the incredibly large, the cosmological, the large time scales, millions, billions of years. So astronomy covers everything. So there's always something to talk about. So Astronomy Daily Live is for newbies, it's for amateurs, it's for the advanced amateurs, and it's for the pros. Everyone is welcome here. I have personally the capability of speaking at um, all of those levels. uh, I do have, my own preferred level, but yeah, it's easy to try to cover the entire spectrum. So easy and fun. I greatly enjoy and appreciate being able to talk to folks at any level that they want. So uh, this is just like um, a gathering of friends in a circle, and we can pretty much chit chat about all things astronomical. Doesn't have to be anything that I necessarily think I want to talk about or anything. If you have any ideas, any thoughts, any questions that you might have, bring them on. Bring them on. There was a rocket launch today, an Atlas V launch that carried another GOES satellite to orbit. And GOES, I don't remember what that stands for. Maybe Uncle Bill can help me out there because I know he's in the chat still. What GOES stands for, but it's one of the weather satellites that is up at geosynchronous orbit and is looking down on the Earth, and I'm looking at the clouds at different wavelengths, and just basically watching the weather patterns, making all kinds of measurements um, to allow forecasters to put that kind of information into their models so they can try to predict what the weather is going to be in the next hour and the next day and the next week and all of that. The one thing that I wish that they would do with the weather forecasts, and uh, unfortunately, I think this would probably confuse more people, which is probably why they don't do it. But what would be really useful, and I'm absolutely 100% sure that they have this kind of a thing, is to present how confident they are in their forecast. Okay, so when you make a forecast like a weather forecast, um, if you make a forecast for the next minute, you your confidence is very, very high. You're pretty sure that certain things are going to happen in the next minute. Okay, in the next hour, confidence is still pretty high, but it's lower, right? It goes down. Maybe you're 95% confident at that point. Making a prediction about what's going to happen in 24 hours, I don't know. Your confidence might drop to 90%, 80%, something like that. Trying to make a prediction about what the weather is going to be a week in advance or 2 weeks in advance or a month in advance, your confidence has got to be really, really low. I would guess, just a rough guess, that uh, making a forecast for a week from today, I would think that your confidence is below 50%. Um, Unfortunately, I don't think that the majority of people would understand that. They would just get more confused because it's sort of like saying, okay, folks, a week from now we have a 50% chance of rain, and we are 40% confident that it's gonna that that um, we think that there's a 50% chance. So that's just going to probably confuse more viewers. But you know, the weather folks seem so sure, and maybe they feel as though they have to, and it's just sort of a thing now that everybody knows. Everybody knows that meteorologists can't really predict the weather all that much. But as a scientist, I would like to put a number next to that, a confidence number. And maybe it doesn't even have to be a number, maybe it can be a color. People understand colors maybe a little bit more. So, if you've got high confidence, it's bright red. And if you have low confidence, it's blue, or something like that, some kind of a color coding, just to show how confident they are in their forecasting. Maybe it's not such a good idea either, because maybe the confidence even for the next day or the next couple hours is 50%, right? So if their confidence in the weather for the next day is only 50% confident that um, their forecast is going to be right, maybe they'll lose a lot of credibility. So, anyway, I digress. I digress. This is astronomy. Although astronomy, uh, there really pays close attention to the weather. Most astronomers, uh, are concerned about weather conditions, especially when they have like an observing run, and they want to make sure that it's going to be clear for whatever thing they're doing. And depending on what wavelength of light you are observing at, that may or may not be a huge concern. If you're observing in the visible wavelengths, or um, the infrared, then you've got to worry about clouds. You have to make sure that it's dark at night so you can't observe during the day. If you're a radio astronomer, the only thing that you really have to worry about is not pointing your telescope at a very, very bright radio source like the sun. Okay, so radio astronomers can observe uh, either during the day or during the night. In radio light, the sky is always black. It's always dark, except of course where there are radio sources like the sun and the moon and the stars and the galaxies and everything else that um, optical or infrared folks are seeing. It's just a different wavelength of light. Now, shorter wavelengths of light, like ultraviolet, X-ray, uh, those things, those don't even get to the surface of the Earth at all. So you have to have spacecraft, or you have to have some kind of observatory very, very high up in the atmosphere, because the atmosphere just absorbs all of that light, either absorbs it or scatters it or reflects it back. And so it never gets to the ground. So if you want to observe the sky in the ultraviolet, you you have to get, as I said, either pretty high up, or you have to be out in space. Um, both of the Voyager spacecraft had spectrometers on them that saw things in the ultraviolet, and I don't know what their status is now, but for a very, very, very long time, those instruments were actually being used as, telescopes to look at stars, galaxies, those kinds of things in the ultraviolet. And sorry, I'm just I've 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 twisted up my cord again. Arr, arr, I hate that. Hate that. So I think what I want to do first, there were a couple of things that I wanted to talk about tonight. The first thing is that I want to do another object of the day for sure. I really enjoy those, and it's sort of uh, it's sort of a fun way to talk about astronomical things with uh, and it's sort of off the cuff, right? It's not anything really planned or canned or anything else. None of this is. This is a very casual, fun. Um, Hopefully, the quality is okay in terms of content. Um, but yeah, just a fun get together of friends each and every day at the same time, same place, just talking astronomy for a while. So I want to do an object of the day first. And then if there's time, I wanted to talk about the recent government accounting office report that came out um, a while ago, talking about the progress of um, the James Webb Space Telescope. But before I do that, this little twisty thing is going to drive me insane until I fix it. So I'm gonna put this microphone down and I'm gonna untwist my 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 cord really quick. This will just take a second, but I can't do it with one hand. So hold on just 1 second. Hold on. Ah, there, there. See, now it's all straight. Okay, thank you. So I think tonight I want to go again to the NGC catalog, and that's the new general catalog. And it's a catalog, of course, of non-stellar objects. These are objects that aren't stars. So galaxies, globular clusters, open clusters, planetary nebulae, and diffuse nebulae. And so I'm going to share my screen. We're going to go to infinity like that. And I'm going to hide that. And we're going to come over here to this guy. And we'll make him really big. And then we'll go to random.org. By the way, I do have my drink of choice tonight. And once again, it is hydrogen hydroxide, HOH. It's sort of my go-to for sure. Once in a while, a couple times a week, I will hit the dihydrogen oxide, but tonight it is definitely the hydrogen hydroxide. Hey there, Tom. Hope everything is going well. I see your wave. Everything is going well here. How was that last 20 million mile trip since yesterday? Did you feel any of that? I I certainly didn't. Anyway, hydrogen hydroxide. Cheers. All right. So we're going to go right into random.org, and the NGC catalog has 7,840 objects in it. And one of the interesting things about the new general catalog is that the numerical order more or less follows right ascension. And right ascension is sort of like the longitude in the sky. It's the east-west direction in the sky. And so NGC1 is going to be very near 0 hours right ascension, and NGC 7840 is going to be very near 24 hours right ascension. So all the way around. So just by looking at the NGC number, you can actually get a relatively good idea about at least east-west where it is in the sky. So I'm going to use random.org here to choose an integer between 1 and 7,840. So we're going to do the drum roll. Boing. All right, NGC 2594. Okay, so NGC 2594 is, let's see, 7840. I just pulled out my handy dandy calculator, and 2594. So that's about a third of the way through. So a third of 24 hours is about 8 hours. So this is going to be around 8 hours, right ascension, which places it about 3 hours east of the constellation Orion. So it's this object is at least in my location right now is actually probably visible. So what I like to do is I like to go to an astronomical database called Simbad, and it's hosted in France. I've used Simbad for about a million years, and it's changed over the years too. But it's I haven't really noticed a difference between these different astronomical databases. So one's as good as another. This one's okay. I don't have any complaints. So what was it? NGC 2594. And my guess also um, is that this probably isn't a galaxy, but well, I don't know. Let's find out. NGC 2594. Simbad search. Ah, it is a galaxy. There's a lot of galaxies. Definitely a lot of galaxies. And yeah, as you can see here, the right ascension is 8 hours, 27 minutes, 17.186 seconds, and a declination of positive 25 degrees, 52 minutes, 44.17 seconds. So let me, don't know what constellation that's in. It's going to be over there somewhere. Let me grab my charts really quick so I can find this on my charts. Hold on one sec. Now I don't think I'm going to show you these on my charts anymore because it's just too painful. It's too painful to do that. But I'm just going to go to my charts and open them up here and see. It looks like it's going to be on chart number 6 of the Wilterian's Sky Atlas 2000. It's going to be 8 hours, 27 minutes, and plus 25. And it's NGC 2594. Okay, so that's not necessarily showing up on these charts, but it's right next to the Beehive cluster in the constellation of Cancer. So that's pretty cool. As you can see by the picture there, this galaxy is very near what looks to be a bright star, pretty bright star. So let's see. So this is the galaxy type. It's called an SB0. So S means that it's a spiral. B means that it's a barred spiral. So it has a sort of a bar through it, and yeah, you can sort of see that here. It's kind of hard to tell because it's an SB0. The 0 means that it's a very, very compact spiral arms. So it's really kind of hard to even see if there are any spiral arms there or not. We'll come back to the picture momentarily and check that out a little bit more. It looks like this galaxy relative to us is moving away from us at a velocity of 2,350 kilometers per second. So that's whipping out there pretty fast, pretty fast. Of course, this is a galaxy, so this is not inside of our galaxy. This is a separate galaxy far, far away. And most likely there will be some information about distances here as we move down. So all this stuff here, oh, okay, well, here's the angular size in arc minutes. So one arc minute is 1/60th of 1 degree. So this is 0.567 arc minutes long and 0.385 arc minutes wide with a position angle of 35 degrees. So I guess what that means, if this way is north, you see how it's sort of angled this way? Apparently that's about 35 degrees. Yeah. So all these other numbers are magnitudes in different wavelengths of light. The B and, well, pretty much just the B is sort of a visible wavelength of light. J, H, and K, those are getting more into the infrared. U is definitely visible. G is visible. R also is visible. I and Z are also um, infrared. So at least in the visible wavelengths, this is a very faint galaxy. Okay, 15th magnitude is very, very, very faint. That's like 9 magnitudes fainter than what the human eye can see. So thanks, Uncle Bill. Yeah, I should mention the Discord server that I have, which you can find a link to it down in the description of this video. So Uncle Bill is kind enough to put some pictures of the object of the day into that server each day. Greatly appreciated. That is very, very awesome. So pretty faint, right? In order to see this galaxy, um, you need a pretty sizable telescope. Uh, just to be able to put your uh, um, um, eyeball on it and see it, ooh, you're going to need probably a 16-inch telescope or more. An 8-inch like the one I have, you definitely would not be able to see this. Now, if you use like a camera, some kind of a CCD camera, and did a long exposure, and you're able to track it, then yeah, you'll probably be able to see this. But as noted before, it's next to this really looks like a pretty bright star there. So, how do you do a long exposure to get this faint guy and not have this bright star just wash everything out? That's a pretty good challenge. Pretty good challenge. So, pretty faint galaxy. Now, sometimes what that means is that it's pretty far away, right? The further something is, it tends to get fainter and fainter and fainter as it goes away. So we'll hopefully be able to find out what at least the measurements are in terms of how far away it is. Now, most non-stellar objects have a bunch of different names, and this one is no exception. So it's NGC2594. but it's also all of these other names, right? All these other names. Now you notice, sometimes uh, uh, we sort of, laugh at these names because, the names are just these weird numbers, right? But if you look carefully at least some of the numbers here, okay, these numbers actually have some meaning, right? 827, 1718. Well, that's just the right ascension here. 827, 1718, right? And then there's a plus. 25, 52, 44, 1. 25, 52, 44, 1. So most most of the time when you see numbers like that, especially if it has a plus sign or um, like a minus sign, that's usually the position of the object in the sky. It's just the right ascension and declination, usually, right? Now, it's interesting, that none of these numbers match exactly, and you got to wonder why. There sometimes are good reasons for that, depending on what wavelength of light you're looking at. Um, um, Especially when um, you're trying to measure the position of these extended objects. A star is essentially a point source, but a galaxy isn't a point source. It's a it's a blob, right? It's a blob. It isn't a point. And so, you know, when you have a blob like this, where is it? Excuse me. So where is it? Well, they try to measure what's called the centroid, which is sort of the it's not necessarily the brightest point, but it's sort of the center of mass, the center of brightness. And sometimes, depending on what wavelength you're looking at, uh, that center of brightness will change. And so that's probably why these are slightly different. Could be. See what else we got. So apparently, this galaxy has been referenced in scientific papers 35 times in the past 20 years. So that's not too bad. We'll come back to that one. We do have a distance measurement. So let's look at the distance measurement. Usually these are in megaparsecs. Yeah, and this is no exception. So a parsec is 3.26 light years, and then we multiply that by a million because that's what a mega is. So 3.26 times 1 times 10 to the sixth, and then we're going to multiply that by 35.1 because it's 35.1 million parsecs. So 35.1, and that brings us to woohoo, 114,426,000 light years away. Yeah, why so many catalogs? Main, that's a good question that I don't necessarily have a good answer for. Um, Primarily, um, these were surveys that were done, and they identified um, um, these objects for certain characteristics. If this object has a certain um, characteristic that a survey is looking for, then it's going to be added into the catalog, into that survey's catalog. So that's at least one explanation. There may be other explanations as well, but it um, it can also be that, just one catalog thinks it has a better one, than somebody else's. And so, they name it a different name, and that's what it is. It keeps us on our toes, right? It keeps us on our toes, and um, yeah, yeah. You just have to be aware that one object may have several different names, just like people, right? Sometimes you're called Tom, sometimes you're called Hey You, sometimes you're called maybe um, you know all kinds of different names, right? All right, so this guy is pretty far away, 114 million light years away. So what that means, just to put it in perspective, is that if I were to go out tonight and look at this object, the light that I'm seeing from it right now started from that object 114 million years ago. So that's pretty far out there, pretty far out, literally far out. uh, I don't know what these things are down here. Herschel observation logs, and they have these other things. Let's go into Ned. I guess I like to go into Ned too. See what Ned has to say about NGC2594, the NASA IPAC extragalactic database. Let's see what they have to say about this guy. Again, here's the list of names. So these guys, they show it both in terms of right ascension and declination, and also um, um, equatorial longitude and latitude. So yeah, and also in terms of the um, ecliptical, the um, ecliptic coordinates, and also galactic coordinates. So yeah, they've got them all covered here for sure. Let's see. Most of the time, these numbers just don't agree with with um, Simbad, and that's okay. So the heliocentric radial velocity is 2,362 kilometers per second. What did Simbad say? I don't remember. Let's go back and look. So Simbad said Simbad said 2350. So 2350, 2362. Look, I'm gonna pop up Ned in a different window so we can hop back and forth between them. Just like that. Just like that. Let's see, equatorial coordinates, ecliptic coordinates, galactic coordinates, 2362. So those agree pretty well. So they're saying 0.6 arc minutes by 0.4 arc minutes. And Simbad, what was saying? I think they had more decimal places. Let's see. 567 and 385. So those agree. Those agree pretty well. Magnitude 15. Yeah, yeah. Okay. Calculated and corrected velocities. Oh, all these numbers. Astronomers love to make measurements of numbers. So here's various means of measuring distances. They all seem to agree pretty well. They're looking like they're about 35 megaparsecs away. What was that, 114 million light years? Geometry. See, now this is saying, okay, this is in the Z band, so that's pretty infrared. Yeah, so it's pretty bright in the infrared. It's a lot fainter uh, in the visible wavelengths. Let's see, what else is here? Anything else? That's about it. Let's, I love galaxies. I like to look at galaxies. I like to think about the fact that there's, you know, at least 100 million stars right there. It's just amazing. Blows my mind. And that is so far away. And actually, 114 million light years, that's pretty close. Relatively close. So now we just get to look at pictures. As I said, this is in the constellation of Cancer. And ooh, there's some pretty galaxies up here. Right next to the beehive. I sort of wanted to zoom out and maybe we can see some of the stars in the beehive. I don't know. If I zoom out far enough. Still zooming. The beehive is a very large open cluster. Ah, there it is. Okay, so here's the beehive cluster right here. So here's some of the stars in the constellation Cancer. And here's the beehive cluster. It's an open cluster. And of course, I just lost my position of 2594. There we go. Okay. So, yeah, you can sort of see its proximity to the beehive cluster. So let's zoom in a little bit again here and sort of scan around and see. Here's what looks like um, um, an elliptical galaxy up here. Looks like right next to it is maybe an edge-on spiral galaxy. Probably this guy is in front of this guy. So this guy is sort of between us and this one. This one probably is further away. And there's our guy, 2594, sort of covered by the crosshairs. There we go. And there's a couple more galaxies down here, it looks like. Cool, cool, cool. Oh, did I lose him? No, there he is up there. This thing likes to jump around a little bit. Let's zoom out one more. Yeah, there's some other spirals around here. So everything that you see in this picture that doesn't look fuzzy. So that's sort of fuzzy. That's sort of fuzzy, 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 fuzzy. Everything else sort of has these lines. These are called diffraction spikes, and those are caused by the the um, optics of the telescope that is being used, and you usually only see it with a point source. See, so these stars are so far away that to us, they appear to be just points of light. So all the stars in here are in our galaxy, the Milky Way, but all of these galaxies are way, way, way beyond ours. And there's probably stuff in between, but it's kind of hard to see. There's not a lot of it, and it's usually very, very dark. Stars seem to like to congregate in inside of galaxies and not really anywhere else. Ooh, I wonder what that is. I don't know if that's a defect on the image or if that's actually something. Maybe a dwarf galaxy? I don't know. Hard to tell. Hard to tell. Uh, Anyway, very, very cool. A nice little galaxy, a very, very compact barred spiral galaxy is what that's called. SB0, NGC2594. Well, very cool. Now, this galaxy I could probably see in my 8-inch. That looks pretty bright. Pretty bright. If this is 15th magnitude, this might be 13th, something like that. So I might be able to see that um, in my scope. I wouldn't be able to see anything else here at all. Even these stars are actually very, very, very faint. Very faint. All right, let's go back to, how do I get back to Simbad? Oh, I think it's just going back like that. Because I wanted to look at the references. I'm going to take a sip of this hydrogen hydroxide. Cheers. See if there's any interesting papers about these guys. 35 of them apparently mention this galaxy. Star formation study of the Atlas 3D early type galaxies. So that's a survey. The SAMI Galaxy Survey, star formation associated with neutral hydrogen in the outskirts of early type galaxies, nearby early type galaxies. I don't, I'm going to have to find out what they characterize as an early type galaxy. I don't remember what that is in reference to, but apparently maybe this is an early type galaxy, whatever that means. Galaxy groups. So most galaxies are associated with clusters of galaxies of some sort, so I'm not too surprised at that. Catalog of visually classified galaxies in the local universe. So 140 million miles is considered local. Update on H1 data, Green Bank, okay. So here they are looking at the galaxies in radiolite, star formation histories and stellar population scaling relations, early type galaxies again. I'm not going to go through all these. Looks like there's an interesting project called Atlas 3D. Wonder what that's all about. Measuring redshifts with 2 mass. That's kind of cool. Atlas 3D. There's lots of Atlas 3D mentioning this guy. Identification and designation of galaxies. The K-band galaxy luminosity function. The updated Zwicky catalog, UZC. Aha, UZC. Does this have a UZC number? I hope so. UZC? Ah, it does. Look at that. UZC. Da-da-da-da-da. Cool. So that's a paper that actually may mention this object. How about that? What a surprise. Updated Zwicky catalog, UZC. Cool. Spatially resolved kinematics. Just means how it's sort of internally moving. Accurate positions for MCG galaxies. So is this an MCG as well? It is. It's also an MCG galaxy. Very cool. Very cool. All right. Well, that is the galaxy of the day, NGC 2594. Nice galaxy. Pretty galaxy. Won't be able to see it in my scope for sure. Yeah, you need like a 16-inch or more to be able to eyeball that sucker. Yeah, for sure. All right, well, cool. So I guess what I'll spend the rest of the time on, yeah, good. Yeah, you know, uh, Tom, any kind of tool that you have on hand to make life easier, I fully encourage for sure. Online star atlas, cool. I'll have to check that out. I wasn't aware of that one. Maybe that um, is something I can use in this live stream, as opposed to trying to hold up my charts, which is just impossible, just absolutely impossible. So let me stop sharing my. We'll come back over here and talk about JWST a little bit. I On the weekly space hangout yesterday, Morgan was talking about the fact that um, um, the General Accounting Office just came out with um, a report, which I think I put a link to somewhere on the Discord server, so you can check that out. It's a 35-page report um, that just sort of gives, um, at least from their perspective, a um, a sense of progress with JWST and what it's and I haven't read it all yet, so I'm just sort of paraphrasing what Morgan had said. Excuse me, yesterday, and that is that they they've basically run out of any time in terms of uh, delays, right? They really can't have any more delays because it's just costing so much more. I think it's up to something. It's over 8 billion or so, and really, as far as I'm concerned, it doesn't really matter how much it costs. If they can afford it, they should do it for sure. But what bothers me most is that they um, and as I said, I haven't read this, but Morgan said that they were having some kind of problems with the um, with that um, tennis court sized shield, that they have to put behind it in order to keep it cold. They can't have the telescope in the sun because it's too warm. So they have a shield um, blocking the sun out, and that's supposed to keep it cold. But that thing has to deploy, and if it doesn't, they're going to have some problems, right? Because they're not going to be able to observe at the temperatures that they want to be at. And my attitude about that is that if there's even a slight, well, look, if there's a problem on the ground where they've got full control, right? They can grab onto it. They can, they've got full control of it. If they're having problems uh, with this scope on the ground, sort of this late in the game, that makes me really nervous about um, uh, you know um, throwing it over to L2 and um, hoping that it works. Confidence at least at least with that aspect of things seems very very low. And this late in the game, it's not a good idea. And to say things like, "Look, we've spent $8 billion. We have to launch it. We have to launch it because we've spent all that money. Otherwise, that money's just been wasted, right?" Well, no, not really, because a lot of knowledge has been gained, a lot of experience has been gained. All the materials are still there. All the stuff is there. And what would be worse, as far as I'm concerned, is to spend $8 billion, right? Launch this stupid thing, have it go out there where we really don't have access to it, and have it fail. Okay, that would suck. That would suck big time. And I would much rather either say, look, we're just going to put this on hold until we figure this out. And if there's a cap on spending, so we can't spend any more than 10 billion, say. Okay, well, if $10 billion is spent and it's not ready to go, then you end the funding, you end it, and it just doesn't fly, because the alternative is to throw this thing up there and have it fail, and then you're left with nothing. I mean, well, the only thing that you're left with at that point is just the knowledge gained and the experience gained, which is very, very, very valuable, of course. But you've lost all the material, you um, and you have this thing up there that doesn't work. And PR wise, that's bad. That's really, really bad. I would much rather not do it. If it's not going to work, if it's not going to work, you need to be, you know, 99% sure, or even higher, right? You need to be 99.999% sure that that thing is going to unfold and work, right? And if you can't be that confident, then you don't put it out there until you are. And you know, if it's sitting here on Earth, maybe somebody will say, hey, let's continue working on this. Maybe even the public will say, hey, let's get this working, sort of, regardless of how long it takes, because it's so awesome. I mean, really, 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 it's going to be an awesome, awesome scope. But the other thing that I want to say about that too is that space telescope time is incredibly oversubscribed at this point. Um, I heard that it was at least a factor of 10. Um, Tony from um, Deep Astronomy was saying that it's probably even more, right? So 10 10 times more proposals to make observations are done compared to what is actually done. So you know if you have time for 10 observations, there are 100 that are actually 90 that get thrown out uh, because there's only so much time, right? It's one telescope. The Hubble Space Telescope is one telescope. So, I mean, why not? Why not instead of a single James Webb Space Telescope, very, very expensive, doesn't work. Um, why not um, build 10 Hubbles or 20 Hubbles or 100 Hubbles and throw them up into orbit, right? And um, then you have a lot of space telescope time. Why not do that? I, I think that's awesome. You can have, you know, um, some telescopes, can specialize in, visible. Some specialize in the infrared. Some can specialize in the ultraviolet. But you have 10, 20 of these um, uh, specializing, and then the astronomers down here on Earth uh, don't have to, fight quite so hard for time, right? And they'll get some really awesome data, and you'll have some telescopes that work, and it might actually even be cheaper as well. Now, JWST, obviously, because of its size, it's a big light bucket, big bucket, big bucket. So it is going to be able to do things that Hubble-sized telescopes um, wouldn't be able to do. But there are ways around that too. Um, in space, maybe it's a little bit harder, but you can actually combine the light from telescopes, from different telescopes, um, and just add them up and uh, do it that way instead. If you want high resolution, you can do some kind of interferometric work. Now in space, that's a lot harder, but hey, that's a cool challenge. That's a cool challenge. So why not? Why not? Anyway, uh, I'm I'm fully in favor of JWST for sure. That is going to advance um, our knowledge huge. But if the thing isn't working here on the ground, then you shouldn't put it up, and I don't care how much it costs. Okay, if the thing doesn't work, don't put it up there just because because we've spent all this cash already, and we have to. No, let's get it to work first. And if the public um, is not interested in doing that, then you end the project, and you either mothball it and hope later on pick it up again, or you tear it apart and do something else. So, and that's how it goes. That's how it goes. But do not launch that kind of an instrument unless you are, as I said, 99.999% sure that it is going to work. There's always, HST is a perfect example of that. They were sure, right? They were sure that it was just fine. It was just fine. And their first look was just shit, right? And it's like, oh man, we didn't make the mirror right, okay? But when they launched, they they were pretty sure that everything was just fine. And if you launch JWST knowing that there's even a 1% chance that it's going to fail, you better not do it. You better not do it, because if it's going to fail, it's going to fail then. Yeah, yeah. So don't don't do it. Don't do it. So yeah, and I don't really care about costs, because money, there's a lot of money around. There it just depends on will, right? If if you have the will to spend it. So and at least as far as the United States goes, it can make its own money. So cost is really not the problem here. What I'm concerned about is if they're having problems here on the ground this late in the game, then you shouldn't even think about any kind of launch. It's ridiculous. Absolutely ridiculous. All right, look, it's been a little bit over an hour. I'm going to take one more draught of this fine, fine chemical. Cheers. And I'm going to say good evening and good day. Uh, Make sure to subscribe if you haven't already. You can turn on notifications. Definitely hit the thumbs up or the thumbs down. I'm interested in the absolute value of your reaction, not necessarily if it's a positive one or a negative one. I like to have a reaction. Send a comment down below. Always like to read those. I will respond, at least at this point, to all comments. Um, Make sure to share this video if you know anybody who has an interest in the science um, um, of astronomy. Uh, Make sure to share this around. I am definitely wanting to grow the crowd here for sure, because this is fun. You know, it's a lot of fun, and uh, I am here to stay. I don't see um, any reason to stop at this point, because I'm thinking about astronomy anyway, so I might as well do it here with you. So yeah, okay, I think I'm gonna get out of here for now. Glad you could stop into the circle, and yeah, over the next day, we will have traveled about 20 million kilometers in sort of a spirally pattern. So don't get too dizzy. Try not to think about it, because maybe you will. And I will see you again in a little less than 23 hours. Okay, take care, everybody. Spread the word. Spread the word. I'm trying to grow this channel. Okay, trying to grow this channel. Trying to get more in here. Um, Let me know what I need to do in order to do that. Does the quality need to go up in terms of content? Does the production quality need to go up? The quality of the video, quality of the audio. Um, what what do you think I need to do to grow this? I think the most important thing is time, is time, and um, consistency and patience, and some marketing. I'm trying to be relatively active without being rude. I don't want to be rude. uh, I see a lot of rudeness, and I don't want to be rude, but I also want to be you know um, um, sort of aggressive in terms of marketing. I think I am filling a niche that um, doesn't currently exist in terms of the astronomical podcast world. And yeah, I want to make this better. I always want to make it better. So any any ideas in terms of how I can do that? You know, should I have some guests on? I would definitely like to fill up um, panel things here. I want to get the audio running on this machine. I'm working on that. I tried an experiment the other day. It was a failure. So yeah, I'm gonna keep trying. I definitely would like to get some sound going on this as well, even if it's just space music um, um, playing in the background. I think that would be very, very cool. Of course, that would be my own, or getting the permission from somebody to play theirs. But I think having some background sound, I think that would uh, that would probably make this a little bit better, instead of just having to hear blah 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 all the time. So yeah, working on the background sound, but any kinds of suggestions, I will take it because I want this channel to grow and this live stream to become more and more popular. I just want to take over the whole thing. So no, 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 no. There is room for all of these things, and all the current um, podcasts and live streams uh, are awesome, are awesome, and hopefully they won't stop either because I like to watch them and I like to share that space for sure. So okay, I'm gonna get out of here for now. Take care, peace, and I will see you in about 20 million. All right, bye.